Can I have your attention, please? Thank you. All right, so 11.4 vectors in trigonometry. Today when we go through this lesson, there's going to be different times when you're like, well, maybe I can try it this way or I can do it this way. I'm telling you, I'm giving you the easiest way to do it. The book will explain it a bit different. If you watch any of the other online videos, they may explain it a bit different, but I really have found more success teaching it this way than the other way. So, first of all, defining vector. What is vector? Lily?
Any quantity that has a magnitude, size, and direction.
Okay. Good. A quantity that has magnitude, size, and direction. You have to have magnitude and direction. Vector. Our panda back there, his name is Vector. Very cool. Okay. All right, so questions 1 and 2 on page 563. Number 1. Let's check it out. Number 1 says, does the sentence contain enough information to describe a vector? All right. Volunteer? Nick, part A? Yes, Nick says yes.
No. It doesn't have the magnitude.
Hold on. Go ahead, Nick.
Because it gives Oh, no.
Okay, so it gives a direction, right? Doesn't give a magnitude, so this one won't work. There's no magnitude. Okay, so you have to have magnitude and direction. Hey, how about part B? How many say yes? How many say no? Okay, Bennett, why are you saying no? Just curious. I'm not saying you're right or wrong. Now you're saying never mind. All right. A hiker walks 5 miles per hour in south. So here's our direction. Here's our magnitude. So yes, that one's good. Okay, letter C. How many say yes? No. Okay, Eli, what's wrong with it?
It doesn't give a direction.
Good. No direction. All right. Better than that other band. Okay. All right, number 2. Two sisters. Oh, any questions there? All right. Two sisters, Alethea and Shanice, I think. Shanice, sorry. Yeah.
I didn't butcher that.
Alethea and Shanice, also known as Shanice. Okay, drive from point A. Pay attention. Drive from point A to point B. Describing their trip, Alethea says we ended up 71 miles northwest of where we started. Shanice says we ended up 50 miles west and 50 miles north of where we started. Explain why both sisters' descriptions of their trip are accurate. How many drew a picture of the trip?
It's right there. I haven't started yet.
Okay, if we haven't started it, I want us to draw a picture. And whenever we're drawing pictures like this, we use an XY axis usually. Just kind of like a compass.
It's in the book.
Yeah.
Oh, it is?
Mm-hmm.
Oh, whatever. Silly book. Okay, well, I'm going to draw from here. We always start at the origin. Do they show that?
Yeah.
Okay. And then we go north, or 50 miles north of where we started and 50 miles west of where we started. Think of a compass. This is?
North.
That's the easy one. This is?
South.
What's this?
East. West.
All right, very good. So, if we're looking 71 miles northwest, we're here, okay? And we label it 71. This one's going 50 miles west and then 50 miles north. These little lines I'm drawing on the paper, those are our vectors. Our vector usually is attached to the origin, though, okay? So that's the vector we're talking about. But anyway, 50 and 50, what type of triangle is that?
Oh, right triangle.
Right triangle. So why are they both accurate? Bennett?
They're kind of, the hypotenuse is kind of like the displacement, and the other sisters are talking about the distance, and when you're adding and subtracting vectors, they just end up being the same thing, since you end up in the same place.
Okay, so do they end up in the same place? How could we verify that?
By testing Pythagorean theorem.
Good, doing the Pythagorean theorem. A squared plus b squared has to equal c squared. So 50 squared and 50 squared, that gives us a total of 2,500 plus 2,500. And that happens to be 5,000. What is 71 squared? Is that 5,000? Or pretty close to it?
5,041.
Yeah, it's 5,041. So it's pretty close, right? So you're about there. That's why they're both true. This is actually 5,041, but that's okay. All right. How many have studied vectors before? Oh, good. So we're good. Well, then let's look at our assignment. Here we go. Example side. Describe each vector by using ordered pair notation. Give the coordinates to the nearest 10. All right, I want you to talk to your neighbor real quick and describe what you're going to do there. What you think you should do. Get 30 seconds. Talk about it. Actually, we'll go a minute. Here, what do I do? Go ahead, Bennett.
So could you already have, if you draw a line down from like where the arrow is down to the x-axis.
Okay.
Yeah, and then you already have 129 degrees. So then you can figure out what the line you just drew is and along the x-axis.
And that will give you the coordinates. So if I found this length, I'd know x at coordinate. I found this length, I'd know how far up the y-axis I go.
Yeah.
True. How can I find those lengths? Yeah, using SOHCAHTOA. This is a right triangle. Well done. How many thought that? Okay. Now we can always find those right triangles. Now pause for a minute. Everyone stop. Because this is where you'll want to go through that process. And that's great to go through it. But if you look at, say, like number 2, I'm assuming, by the way, this is your vector. We haven't officially introduced. Everyone say hi, vector. Hi. Okay, all right. This is our vector here. Okay, so, hey, sorry, hi. That's all right. So your right triangle could either be here or it could be here. And some of you may look at this one and say, well, my right triangle's here. I guess it could be here as well, right? Sorry. This one could be here and it could be here. All right, what I'm going to do is I'm going to try to get us to think of this in the way that we think of trig. Okay, when you guys are doing trig at this time next year, it gets much more complex, and we use this type of picture a lot. In fact, this vector, if you've ever seen those movies where they have like a radar map and this thing's spinning in a circle and it's going beep, 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 and you see a little bleep, and they're like, whoa, there's the destroyer, it's coming to get us, and you know, it's all scary. Okay, well, this right here, that's what this vector does. It just sweeps in a circle. And when we're in trig, we use this thing called the unit circle. It looks, introduce you to the unit circle. You will come to love the unit circle. But there it is right there, the unit circle. We use that a lot. You have to remember all the different pieces on it. Okay? You'll remember it next year when it comes back. Okay? Well, what I want to do is I want to explain that we always start right here. Our vector always starts on this axis right there, where y, right on the y-axis. So if you're taking notes, we'll talk about that as being like, it's called our standard position. It's where we start. And then your vector starts moving counterclockwise. Always moves counterclockwise. Now some of you have tuned me out. You're like gone all of a sudden, you're not paying attention. This is the key to you understanding this. Not to mention, it is now the foundation of your trig that you'll be doing next year. So if you have me for trig, I'll be saying, hey, we did this last year. And Vogel will be saying the same thing because he's saying the exact same thing I am right now. Okay? This is standard position. And it sweeps counterclockwise. That means from standard position, my vector has now moved from here to there, 29 degrees. In order to find this coordinate, which is what they're asking for what point are you at up here? The way we do that is we use sine and cosine. Now, if we went through like Bennett said there, he said, well, if you're wanting to find x, there's x, right? That's the length x, and this is the length y. Well, to find that, I would take 29, and I would use adjacent and hypotenuse. Adjacent and hypotenuse is what? Cosine. So if I say x is equal to the adjacent, or the cosine, excuse me, is equal to the cosine of 29 degrees. What did I forget in there? The 100. Where does the 100 go? It usually goes, like if we're setting up this proportion, most of us usually put it right here, right?
Yep.
Now I see a lot of you doing your shortcut. You're like, well, I know it doesn't always go right there. I mean, I end up cross multiplying and I get x is equal to 100 cosine 29. Now how many of you take that shortcut? You don't even maybe write that. You just get to here. You're like, this is what I'm putting in my calculator. Okay, some of you go from here to here. Okay, well, let's figure out y real quick. Everyone write down the proportion for y. We'll come back to x here in a minute, but write down the proportion for y. Okay, so we should have y over 100 is equal to cosine 29. Or, excuse me, not cosine. Sine 29. And that ends up giving us 100 sine 29 equals y. Ray. We couldn't use tangent because we don't know opposite and adjacent.
But if you figure out x, then you would, and then you just
You could, as long as x is a perfect number. And if it's a perfect whole number, you could. But what I'm going to try to do is explain how we use both of these all the time. Okay, we're going to use this formula called r cosine theta to find x. And we're going to use r sine theta to find y. R cosine theta, R sine theta. Now I want you to tell your neighbor what the R stands for and what the theta stands for, what you think they stand for. Hey, can anyone tell me what the R stands for? Eli, what do you think?
Radius.
Yeah, it's the radius. The radius in this case is the length of your vector. It's the magnitude of your vector. That's what R is. Okay? We call it the radius because we're talking about a circle, right? Not the Great Pumpkin circle. Circle. Okay, radius, which is also your magnitude. What does, this looks like a 0, it's called theta, it's the Greek symbol theta. What does theta stand for? If this represents this, what is theta? Trevor?
Diameter.
It's not the diameter. Nick?
Circumference.
It's not the circumference. Look at this. This is r cosine theta. What does theta stand for?
Is it the angle?
It's the angle measure. Theta is your angle measure. Now it's your angle measure from the standard position. I probably could have wrote that in a bit better, but it's your angle measure from the standard position. Okay? And that is such blurriness. It's a little better. All right? So let's kind of summarize this. To find this coordinate, we have to use r cosine theta, r sine theta. Thank you. R cosine theta, r sine theta. That is going to give us our measure. Now you'll notice that my little parentheses don't look like parentheses. They're these things. That's how we show vector. That's called vector notation. Okay? So we use those little pointy brackets there. Okay, so right now I want you to take r cos theta, which happens to be 100 cosine 29, and r sine theta, which happens to be 100 sine 29, and find those exact coordinates to the nearest 10. Okay, so hopefully we're doing 100 cosine 29 gives us 87.5, and 100 sine 29 which gives us 48.5. So 87.9 and 48.5. Oh, 87.5. Thank you. Okay. Hey, I think you got it. Okay? Let's move on. Let's try number 2 then. Everyone take a look at number 2. Give it a go. I want you to tell your neighbor how far you've moved. What's your theta when you're doing r sine, r cosine theta? Remember, cosine goes with x. We're going alphabetical. Sine goes with y. So cosine's always your x, sine's always your y, just like alphabetical order. Okay, so we don't have a bunch of frustrated students here in a minute. What's theta? What's our angle?
32.
Angle is not 32. Eli? Angle is, starts here, remember. Angle is 90, 180, 270. Keep 270, 302. It's a 302 degree angle. You always start here. So 90, 180, 270, plus 32 more, or 302 degrees. Should your x value be positive or negative in this quadrant? How many say positive?
Wait, your x value?
X value. Should your x value be positive or negative? How many say positive?
Positive.
How many say negative? Everyone answer the question. X, positive or negative?
Positive.
Positive? Negative. Okay, hold on a second. So how many say y is negative? Why is y negative? Yeah,
Because it's below 0.
good. On the y-axis, you're below 0. It's down here. You're looking for this point, which corresponds to this point on the y-axis and this point on the x-axis. Positive over here, negative over here. Positive on x, negative on y. When you put these things in, you should have r, which is r is what? 75. 75 cosine 302 and 75 sine 302. Okay, what's 75 cos 302? What's that? 39.7? Okay. And what's 75 sine 302? Negative 63.6. Okay, what do I need to see work-wise? I need to see at least this and this. So show me that, because that's what you're putting into your calculator, and then I need to see your answer. Okay.
Can you keep the vector sign there?
Yep. All right. Hey, we're moving on. Example number 2. Everyone read the directions for example 2, please. Oops. Find the distance and direction of each vector, round to the nearest 10. Okay, I want you to work with your partner. You get about 3 minutes to kind of work on number 7 there. Okay, let's see how we did. Number 7. What do we do? Go ahead, Hannah.
Pythagorean Theorem, where you go 40 squared plus 31 squared, and I don't remember the number, and square that, and you get about 55.6.
Good, so we can use the Pythagorean Theorem. So a squared plus b squared equals r squared in this case. So, thank you.
And then it's
So-
southeast.
Good, so we get 40 squared is 1600. What's 31 squared? What's that? 961. Okay, so r is
50.6.
50.6. Okay. All right, and then some of you are just saying, I heard you just saying it's southeast, right? Okay, now that's not how we find that. We actually have to come up with how much of an angle it is. And we're always going to classify it as south or north of east or west. That makes sense? So if I'm here at the east-west line, we are going which way? South or north? We're going south. So the direction is some degree south of east. We need to figure out what degree that is. So in other words, I need to know what this angle is right here. All right. Any thoughts on how to do it? Jordan?
You could make it tan x equals 340.
Good. So if we call this x, we could say that this angle, the tan of x, is equal to opposite over adjacent, or 31 over 40. Cross multiply to get 40 tan x. Oh, hold on. Sorry. Yeah. Choose the inverse tangent there. Finding that angle. Inverse tangent of 31/40. So x is
37.8.
37.8 degrees. That's south of east. So there are two answers. So here's our magnitude. Here's our direction.
Do you want them together or separate?
You just write them like that. That's okay. Any questions there? Go ahead, JJ.
And how much work would you show on this?
You need to see whatever you're putting into your calculator for sure.
Even the square and stuff?
No, just like your final tangent piece. Yeah.
Oh, okay.
Hannah?
How do you know it's like south of east and not east of south?
Be- How do I, because, well, that's a good question. How do I know it's south of east, not east of south? Because I'm telling you that we're going to classify everything as south or north of east or west. Okay, so you're going to use your horizontal line as classification. Good question. Other questions? Hey, please note, Jordan used 31 and 40. She didn't use the 50.6. You want to avoid using that to find your angle if that's a rounded value. Okay? So since it's rounded, we want to avoid using that as our angle, or to find our angle. Okay, we're going to be done there. Kind of past our time limit here.